Okay. Hello, everyone. Do you see me? Nope. Yeah, okay. So, welcome everyone to our second Angular stream. Please type. Wow. Wow, sorry, I just heard myself in the microphone. Sorry, everyone. So, if you can see me, if you can hear me, please type plus in the chat so I know that everything is all right. Great. Thank you, everyone. So my name is Diana. I have worked for YPAM for almost 2 years. And this is my colleague Arcangelo. Today we will talk to you about the modules, services, and dependency injection. And Arcangelo will tell you more about the routing. Okay, I think we can start. I will share my screen. Please, again, type plus if you see everything okay. Okay, do you see my screen?
Yep.
Great, thank you, Angelo. Okay, so today we start with models. 1 second. Okay. Okay, so in Angular module is a mechanism to group components, directives, pipes, services that are related into one place or block. And basically your whole app will consist of modules. Angular understands that you created the model if you have ng model decorator. By the way, you can see the example of model on my screen. Here is this ng model decorator. So in other words, if a class have ng model decorator, it's a model class, and it takes metadata object that tells Angular how to compile and run your code. But why do we need models in Angular? There are several reasons. We could see them on the screen. There are, of course, modularity and code organization. It helps, Angular models helps you to organize your applications into some blocks of functionality. And it's especially important if you have a larger application, because if you don't have some structure, it would be hard to navigate and understand the project very fast. Also, we have reusability by segmenting our applications in the models. We can easily reuse these models across different parts and not repeat our code. Scope management, it means that modules allows us to maintain clear boundary and scope for services which we declare, and it could be also components, directives, pipes, whatever. But it's also useful if you want to avoid naming collisions and if you want to uh, avoid unintended service sharing. And we have lazy loading, but I think Arcangelo will tell you more about this later in his talk. Yeah, okay. Another point to mention for the models in Angular, it's that there is new feature starting from the 14th version of Angular. We can create standalone components, pipes, directives. You could see example. Basically, we just need to add the property standalone true, and don't forget to import all necessary dependencies for this component, that's it. And why would we maybe use it? It's because the approach with the module, if you create models for your applications, can sometimes lead to unnecessary dependencies, and it could increase bundle size, especially if certain components do not utilize all the exported components, directives pipes from another model, for example. Um, in this example on the screen, we have two components. It's sorry, two models. It's shared model and feature model. And the shared model exports three components from that he declared. It's component A, component B, and component C. And let's imagine that our feature model only needs one component from this shared module. It's component A. We would use only this one component, but anyway, since we import the whole module, we would bundle the all three components in our applications. And we could avoid this if we break our larger modules in smaller one, more focused on the functionality, or maybe utilize some shakeable services to ensure that code ends up in the final bundle only if we really use it. Or also we can use this new functionality from Angular, standalone components, pipes, directives as a solution, because if we use them rather than importing entire module with potentially unused components and services, standalone components allow us to create individual components that are encapsulating their own functionality and their own dependency. Uh, okay, actually, I didn't try it myself, but there is this comment from Angular that allows you to um, modify your app from using models to using standalone components or pipes, whatever. There is like three options: convert all components, directives, and pipes to standalone, remove unnecessary engine modules, and bootstrap the application using a standalone API. If anybody of you is interested, you could try and check the results. But once again, didn't try it myself. And also important point that this standalone functionality, Angular have it from 14th version, but till now I didn't see it in real projects. But I think probably they would become more popular in the next years. Also, I will attach some links at the end of the presentation that you could check if you're more interested in this one. Okay, next, let's talk about app structure. So basically, our app more often than not have the next structure. It's core module, shared module, app module, and features module, of course. So app module, it's like entry point of app, and every Angular application, uh, if we don't consider the standalone one, every Angular application should have at least one ng module class. And the app module is our root module. Um, then we have like core module. In core module, we would have fundamental parts of our app. So if, for example, if you have some service that you will use across the whole app, it could be, I don't know, maybe some logger service or components like navigation bar, header, footer. They would be in your whole application. So you could probably add it to the core module. Essentially, you would add to the core module things that you set up once and then use through the whole application. Um, and it's not only like components, services, it could be also interceptors, some interfaces, so every basic block. Then we have more often than not shared module. In shared model, you would place some like command ground. It's, for example, components that you will use in different modules, like custom button, custom menu component, maybe some pipes, directives, and so on. Everything that you will then reuse in your app, but that are not in the core module. And then separate feature models. Basically, it's not one module, it's however many models you want to, that will be responsible for some separate parts of your app. It could be, for example, dashboard module, if you have that. Could be some user page module, product list module, basically every separate functionality of your app that can stand alone. You would probably create a module for that. I can try to show you. Please let me know if you can see my visual code. Archangelo, do you see my visual code?
Nope.
Nope.
I still
One
see your slides.
okay, 1 second. I will try to share. Okay, what about now? Do you see my
Yeah,
screen?
now it works.
Okay, great. So let's create the structures that I talked about, and we would start with. Okay, we can probably start with app module. It's already generated for us when we run this command ng new. It creates the whole application, and app module is created for you. Here we have this ng module decorator, and there is declarations, imports, providers, and bootstrap. Yeah, let's create. For example, core module. For that, we use ng generate module core command. Okay, and here is the model that is created for you by this command. Let's also add the shared and features. For example, let's create dashboard model that I talked about. By the way, I talk about features, but it could be whatever you like. It could be modules, it could be pages, functionality, I don't know, whatever you name. And it's important to note that this whole app structure isn't set in the stone. It usually depends on the project demands, on the command, on the team desire, and so it wouldn't usually be I mean always be this structure, but usually you could meet this one. um, okay, let's also create. Okay, we have core features shared. Okay, so basically the structure would be, I would create this with the comments because it would be too long, but probably it would be something like that. We would have components, we would have some services, maybe interceptors, interfaces. So like general structure. So there isn't anything, but probably it will look like that. And in dashboard, it would be the same. You would have some components folder, interceptor, maybe not interceptors, okay, but services, interfaces, and shared the same one. It would be components, interfaces, services, pipes, directives, whatever you will later reuse. Okay, I will share my slides again. Okay, let's move on and talk about services in Angular. So, service in Angular in context of Angular means some class that provides a specific set of functionalities to various parts of your applications. We would like have these benefits if we use our service. It, of course, modular design. You extract some common functionality into the service, and that helps you avoid code, because later you would reuse this service. In you could even reuse this service in the separate components. I don't know, maybe directives and so on, state. Um, Also, services helps us centralize our logic. So if you need to update later some code, or maybe fix some bug, you know that you will look it into one service, and probably the problem will be here, or some update will be done only here, and you don't need to look for the whole applications. Important point is that service handles a specific logic or maybe data retrieval process, and the components should focus only on presentation and the user interactions. So all business logic should be encapsulated in the services, and the components only will display this data in the template. For example, let's imagine that you need to retrieve some data from backend, and then convert it to display it in the table. You usually would create two services for that. First one, it would be something like API service that will only be responsible for retrieving the data from backend, and then maybe some converter service, data converter service, that will convert data for you. So every service will be responsible only for one functionality. Uh, yeah, on this slide, it's like basic example of the services. For example, it's logger service. We declare the decorator injectable and provide it in the root, meaning the service would be singleton for the whole application. Here is the methods of service, and then we just use dependency injection to inject the service in the component and use methods from this service. Okay, let's talk about singleton that we already mentioned. So term singleton means that particular class in your application would have only one instance during the lifetime of your app. So when it's applied to services, and it ensures that there is only one instance of your service, and every component that uses every module that you imported, it would be the same instance. And since there is only one instance of the service, any data stored in the service is shared across the components. And it's useful for sharing information or state between unrelated components. And there is like why, because there is only one instance, every update that you would make to the service would be immediately reflected on the all components that are using this service. Okay, there's like two ways to make service singleton. It's like it's using provided in root, and including service in the app module, or maybe in the module that imported only once in the app module. It could be, for example, core module. Let's probably see example. I will try to show you how it works. Sorry guys for constantly sharing, but I don't know how to do it right. Okay, I will share the visual code again. Let's create two components. I will create them in the features dashboard, components, and let's create the first counter. Okay, let's check. Oh, okay. There is typo. 1 second, I will fix it. Okay, sorry guys. 1 second. Dashboard. Okay. Hmm. Okay, 1 second. I will do it like this. Okay, engine generate features, module features, dashboard. Then components. And second one. Okay. So comment added these components to declarations automatically, but if for some reason it doesn't do this, you will need to import it. There is from the typo, and we would need to also export these components. Okay. And add also the module, so we can use these components in app module because I want to add them to the app component. Okay, I will delete this is basic the file that was created during the generation of the application. Okay, app first counter and app second counter. Okay, let's check that everything works. Okay, command is running. Let's wait a bit. Okay, you probably don't see my screen, but anyway, I will try to finish writing and then we will check together. Okay, we have two components. Let's add counter service. I probably didn't create it. Future dashboard. Okay. I will create the service counter in the services folder in the dashboard module using the command engine generate a service. Let's try. Okay, counter. So basically, let's create some count. I probably taking too much time. Guys, if you don't know what is behavior subject, it doesn't matter at this stage. There would be the lecture about this later. For now, it's just a value that would keep the count current value for us. Also, let's create two methods, increment and decrement. This count next. Increment this count value plus 1. And the same for decrement. Decrement and value minus 1. Okay. Let's add this service to our components. For this, we would use the dependency injection. Okay, public counter service. Sorry. And also you would need some methods for incrementing and decrementing value. We would call the method from the counter service, in that case increment. For the decrement, they will be basically the same. By the way, let me move it to the bottom. And decrement. And we would need, I will probably copy that because it's taking too much time. And count. We would take this value, the count value from the service also. Let's for now create it here in component. Behavior subject. Okay, let's take a value from the service. Counter service count. Okay, I'll add 2 engine unit. There is needed only one. Okay, it was second, first. And we would basically copy all the same for the second counter. But change second component. And let's copy also the logic. Okay, guys, you don't see my screen, right?
Not
Okay,
I see
okay,
code.
sorry. Okay, I will try to share, but I don't understand why I could share only one screen by the time. Maybe I'm doing something wrong.
Probably you are sharing a task and not the
I
screen,
don't
the
know.
entire screen. Yeah.
Okay, guys, sorry, but I don't understand, so it will be like that. Sorry. Okay, so what we was trying to do is to show us that when we declare the service is provided in a root, we have only one instance for the whole applications. So if I change the value in the first component, like this, the value would be changed and shared to the all others components. Yes, that's it. Let's try to do this service not singleton. Um, and provided it for every component. Um, we would do it with the help. We can delete this one and use provided for every service providers. For with the providers, we could provide the service new instance for the service every time the component is created. So this service wouldn't be singleton anymore. Okay, and once again, let's show you the screen with the component. Let's check. So now when I change the value for one component, it doesn't change the value for the second component. And so every service state is unique for every component. Yes, let's move on. Later, next, one moment, I will share my screen. Okay. Also, it's important to note that there are not only like root provided in, we could also have uh, some module, meaning that you provide the service to some specific module in your application. Any means that it's provided for whole application, but for every component it would be the new instance of this service. And platform, it's not unique, but not you wouldn't see it very often, because platform is registered in a special platform injector that is shared by all applications on the page. So if you have I don't know, 2, 3 applications on the one page, you would probably use this platform. If you want to use singleton for every one of the app, it could be useful, for example, for micro front end. And let's move to injection token. Here is the example of this injection token. Injection token is used. No, I probably skipped something. No, it's okay. Sorry. Okay, so with injection token, you can provide some value. It could be not object, but string number, and you could inject it in the some service module. I don't know, directive, whenever you want. So injection token is useful in the situation when you want to inject something that might have multiple implementations, and you don't want to use types, or maybe if you want to inject not some class, not component, but not service, but some value like string. Um, And the last part of my presentation is decorators. I listed only three of them that I think is very useful, but there is more, of course. And if you would like, you can check them, Google them if you are interested. But for now, let's talk about these three. So first one we already saw when we talked about the injection token. Um, you use it to inject your token. So with injection token, you just write new injection token, and you provide the name for this injection token, and then use providers to inject this. With inject the decorator, you then use it in the component, for example, or in the service. Um, so it's used with the combination of injection token. The next one would be host. You would usually use host when you want to ensure that dependency will be fetched only from current component or from its parents, but not from any other sources, like, for example, root injector. And the last one, it's optional. Optional, you would write if you have some optional dependency, um, and you don't know if it will be provided or not. So optional decorator tells Angular, so instead of throwing error if there is no dependency, it should return just null, and you could handle it. Um, yeah. Okay, guys, I think it's all from my side. There is links in the end of the presentation. For now, I will pass the word to the Archangel, and then we will have the case session. Thank you very much.
Thank you, Diana. So let me try to share my screen. Okay. Can you see it, right? Diana, can you confirm me, please?
No, I see my screen only,
Mm.
my slides.
Yeah, can you interrupt it?
Yeah, sure. Try again. Sorry.
Yeah. Now? Can you see it? Oh, okay. Thank you.
Mm.
So, guys, today I will try to explain Angular routing. My explanation will be briefly, I hope, even because that part is smaller, I guess. So, Angular is built, as Diana mentioned, demonstrated on with different components. As she said, we can have another component, menu component, footer component, and we have a special tag called router outlet. Basically, the router outlet gives us the power to use the single application, one-page application, and basically you can have a frame in your application where you have
Archangel, sorry. Sorry, if you just share something, we don't see your slides.
no.
No.
Hmm, probably. I'm having your same issue. So let's try now.
Now it's okay.
Okay, now yeah, I see it too. So thanks, Diana. So I was saying that basically you can have different component that are your frame application, where you have header, menu, and footer, and then there is this router outlet where inside you can render different components based on the route, based on the path. And yeah, basically you can also have a nested view with a node component, and inside the router outlet, basically you can put the router outlet in each component you want, even the home. And you could even have a nested root structure, even having the root number 1 on the main root, and the root 2 could have is root config with child 1 and child 2. We will see it later. So let's start. Basically, when you create a module, as Diana just shown, you have to import your root module in your app module, basically. And in the root module, you have to go to you have to define your roots. So let's imagine that you want to create page 1 and page 2. You have to define basically page 1 root and page 2 root, specifying which component will be rendered into the router outlet for that path. Okay, so in this case we have crisis center path, and we will create a component with as crisis list component. We can also pass some, we can also define some parameter in the path, and we will be able to pass this parameter in the root and getting this parameter in that component. Okay, this is basically the entire view of the routing module. And yeah, basically I will show you this later in the code directly, because maybe it's cleanest. Yeah, again, you are creating your definition of a routing module, and you are importing this routing module. So this is the routing module. You are importing this app routing module in your main module. But again, this is for the first routing. You can also do the same for nested routing. So the router outlet. Basically, what I was saying is this: you can have an header component, a footer component, and a main. Into the main, you can have this special tag, router outlet. Here will be rendered everything, every path. So whatever you define uh, um, something in your routing module, it will be rendered here. Header and footer will remain the same in the entire application. And yeah, let's imagine that you have this demonstrate how it works basically. Let's imagine you have two pages, page 1 and page 2. Basically, the HTML will be like this. So header, footer, the same, and here into the main, you will have a page 1 if you put in the path page 1, for example, or page 2 if you put in the path the page 2. And the navigation could be done with the anchor tag with this special attribute, router link. In the router link, you can define the string of the path, and this router link active, it defines the style of the button when it is active, basically. And okay, as I was saying, you can use a string, or you can also use string and variables. So in this case, you have to put square, you have to write square bracket, and as first parameter, you have to put your path, comma, and the parameter that you want to pass. I mentioned just before that you can pass as parameter the ID. For example, in this case, we are passing the username. In this case, in the router outlet, you have to define the path user slash colon username. And this username, in this case, is a variable. And okay, so to use the navigation, you have to import router in your component, and you can also use the navigation not only with the router link in the HTML as we just saw, but even in the component. Basically, you can create a function, your component, that is called from the HTML with a click function that calls this router navigation to a specific path. In this case, so basically I can use or this router link home, otherwise I can create a button with a method click that calls this method, go to secret page, and then using this method, this router navigate by URL, putting the path. It's the same. Okay, so I was saying that you can also pass in the URL some parameter. And for example, we saw before that you can pass username. You can get the parameter in a specific component using the activated route. This activated route gives you the possibility to get params based on the value that we defined in the root parameter. So basically, if we have comma username, we will define here username, all in lowercase in this case. And we can use this syntax, or we can also subscribe using always active root. We can also subscribe params using this structure. It's pretty the same. Lazy loading model. Okay, Diana just mentioned it before talking about module, and today I would like to show how it works and why it is really powerful. And okay, so basically to create a new module, you have to do ng that stands for generate module, the name of your model, and routing to create even a routing file. I'm not sure that it's a good idea to create it right now because I have to switch between screens. So let me conclude my slides, and then I will switch on practical session. And okay, so basically this command will generate a new module, my module, that looks like this. And it will generate even a routing file that will be imported automatically in your new module. It's pretty useful. And okay, so what is the lazy loading module? So basically, when you load your app, if you don't use the lazy loading functionality, at the bootstrap of the application will be loaded the entire application. So it could be slower and less performant importing such component that and you are pretty sure that will be not loaded at 100% of visitors. So to improve the performance of our application, we can use this special feature that is called lazy loading. So sorry. With the lazy loading, you will load your components only when it is needed. So let's imagine to have a page called lazy loaded, okay? That is a children page, okay? You will not load the lazy loading component and files until you don't navigate in that page. So when you will navigate in that page, then you will load this component. And yeah, you can also define into lazy loading module a nested routing. As we said at the beginning, you can have different levels of routings. So in this case, we are defining the main route, and then inside the lazy loading routing module here, we are defining our children. Okay, another special feature that gives to us Angular is the can activate. So basically, can happens that a component or a page should be enabled only on specific requirement. Let's imagine that to enter into in a page, you should be logged in. So you need grants to access in a page, okay? So you can say that to enter in the admin component, you need to be activated. To do that, you can do this. Basically, you can create a special can activate function in your app module, in your app routing, sorry. And basically you are going to inject in the can activate the permission service or the service that gives to you the permissions. Let's see. So yeah, this is the guard implementation basically, okay? So this is the permission service, okay? And here we have the can activate that will be triggered from can activate in the routing module. And basically it will check, it will run the check login. That is our custom method to see if we are logged in or not. Here we can, here basically it retrieves a Boolean to see if you are, if you can be activated or not. So basically, if you can't be activated, it will return false, and you will navigate back to the login page. Otherwise, if you are logged in, you can activate because it returns true. Basically, it is a service, a generic service that I called, for example, out service is logged in, that does a backend request to say if your credentials are right, and then it returns true, or otherwise it returns false. Okay, the can activate basically doesn't say to your application to not load a module. What it does mean? It means that even if you are not activated, you will load any way you will load your module, and it is not so performant. It's not so efficient. So to use the can activate logic with the lazy loading modules, you have to use can match, because the can match is an advanced feature of can activate, because with can match you can do both. You can say to the application to not load that module until you don't are activated. So it's an advanced feature of can activate. Basically, it works in the same way. You have to write can match and then create a can match function that is basically a type from Angular. And here you have to inject your custom service and passing, for example, your token. And yeah, probably I completed my slides, and probably I can go showing something directly with the code. Let me try. Hmm. Okay, can you see my code?
Yeah.
Okay, cool. This time it works. Okay, so let's try. So basically, we can start creating a new page. We can start creating a new page and seeing what's happened with modules. So ngg component. Let's go creating a new component. I'm not using the structure that showed before Diana. That is better, but doesn't matter, just to understand how it works. So pages, let's say no lazy, okay? I'm going to create a new component that doesn't work in lazy loading. Okay, and yeah, let's go now to define it in, yeah, I'm in the uprooting, that is the main uprooting. And let's add here my new path. Let's call it not lazy. And then the component name. No lazy component. No lazy works. Okay, so let's start to run. Okay, meanwhile, we can also add the link user using router link. So I created a toolbar menu in the main app, in the app component, and then we can create no lazy. In this case, we can also pass it as simple string. Yeah. And let's call it no lazy. Okay. Let me open one. Okay. Localhost. Okay. No lazy. So now I'm on the home page. If I click on no lazy, I will go to no lazy. So what I want to show you basically is that if I return back, if I come back to the home and I go to the source, open file, here I will be able to see no lazy component. So this means that even if I am landing to the web application for the first time, okay? So let's try again. Lazy loading, localhost. Okay. I'm landing here for the first time. I didn't open no lazy component. If I go here, I see that no lazy component was loaded. And yeah, it's pretty useless if I don't have to go in no lazy loading module. But now let's try to create a component that works in lazy loading. So here, let's create ngg module, then pages, lazy loaded. Oh, sorry. Okay. This oh, sorry. Okay. Again, page lazy loading and then routing. Now I'm going to create a new module and a new routing module for this lazy loaded module. Okay. Okay, lazy loaded module. Then let's create a component into this new module, for this new module. So ngg component pages lazy loaded, and let's go. Perfect. I don't know, but I have to reload. Okay. Let's create a directory, components. No, let's create it simple, lazy loaded. It's not so good, but yeah, it works. Maybe we can rename it. Okay, okay, it doesn't matter. Okay, now we have, as you can see, we have a routing module and a lazy loaded module. Let's go to define it in our app routing module. And then we can create here path, path lazy loaded, load children. import. Pages, lazy loaded model, and then model and lazy loaded model. Okay. Okay, I have to define sorry, I'm in the wrong one. So let's try, no, here I have to define here the roots. Okay. Even here in the nested routing module, I have to define my new route. So let's say path. I have to define this lazy loaded component here. So let's say every path should land on our new lazy loaded component. Okay, now it works. Yeah, I was missing this part. And then, okay, probably we have to put here our new link, calling lazy loaded. Lazy loaded. Okay. I'm not sure, probably I have to restart just to be sure. Okay. So now we have no lazy and lazy loaded module. So let's try again. We have no lazy component. Let's try to check if we have the lazy component. As you can see, we don't have here lazy loaded component. Why we don't have? Because we don't have navigated inside the lazy loaded route yet. So let's try. Now, as you can see, automatically you can find that lazy loaded module is loaded properly. And then we have the code in place. Any question? Let's open the chat, because basically I guess I don't have much more to show.
Okay, if everyone have any comments, please type them. We will try to answer you.
Yeah, please. So, guys, if you don't have any other question, I will say thank you.
Yeah, if nobody have any questions, thank you very much for joining today. I hope it was useful for you.
Yeah.
Yeah, okay. Thank you,
Thank you
everyone.
all.
Bye.
Bye.